Let's read this problem. We're calculating the heat and we want this quantity expressed in joules when we're accomplishing a temperature change. So we're going to use the equation where the heat, or Q, is going to be equal to the mass times the specific heat capacity of the item times our delta T. So we have our value of mass given to us. Our specific heat capacity is going to be the specific heat capacity of liquid water. Now make sure you match up the phases. We want liquid water. So in terms of our heat capacity, liquid water in joules is 4.184 joules per gram degree C. So we have that value, and we now need delta T. This is a problem where we're heating a substance from an initial temperature to some final temperature. Delta T is going to be the TF minus TI, F being final, I being initial. So this is going to be 19.8 minus our initial temperature. This is expressed in degrees C, so this is 9.3 degrees C. So we have all our values. Now we simply need to crunch this out. We substitute in our values. We have 15.00 grams for our mass. Specific heat capacity, as we said, is 4.184 joules per gram degree C. And our delta T is 9.3 degree C. Before we chunk this out, let's check our units. We see grams cancel, degrees C cancel. Our final answer is in joules. Okay, which is what we want. That's good. So let's go ahead and calculate this out. And as always, I suggest you do this twice just to make sure you don't have any key punch errors. I get 583.668 joules. Now we'll go back and consider sig figs. Let's see here. We have 4 sig figs. This also has 4 sig figs. However, our delta T, since we can only go to the tenths place, has 2 sig figs. So we want our answer expressed with 2 sig figs, which means we have to use scientific notation. As a first step, let's convert this to scientific notation. This becomes 5.83668 times 10 to the second joules. Okay, we know that because we have to move the decimal place 2 spaces, and this number is greater than 1, so this is going to be a positive exponent. So now we apply our sig figs. 2 sig figs, the first number we drop is less than 5, so we're going to round down. We're just going to get rid of all those other decimal places. And our final answer is 5.8 times 10 to the second joules. When you do problems this way, make sure that you don't leave off that exponential part. Sometimes people forget the exponential part and would not include that and just write this as 5.8 joules. Okay, obviously you need the exponential part. I just mention it because it's easy to overlook that.